So what we are looking at today is we're going to look at the first transformation, which is horizontal and vertical translation. All right? So this is the basic one that you should know, which is left and right, up and down. We're going to look at transforming functions. All right, this is important so you know what we're doing, because I'm pretty sure there will be one question in the exam on that. All right? And also, the book that we are using doesn't really have a lot of good function translation. So what I've done is I found another book with quite a bit of function translation. So here I've uploaded it, and you can actually start doing it. I'll go through it a little bit later. Now, so for today, you should know an understanding between the difference of function of x plus c and function x plus d. All right? That's basically x plus c in the bracket is moving left and right. X plus d is moving up and down. All right? So here, if I indicate that as left and right, and this is up and down. All right? You can see that left and right is parallel to the x-axis, and up and down is parallel to the y-axis. All right? So a little bit of solving algebraic problems, not a lot. Now, for linear transformation, I am actually going to use quadratic as an example. So in this case, the linear transformation is a change in the graph that moves all points in one line. So here, I've got the red line. I've moved it down to the blue line. All right? Just remember one thing, the red and the blue, they are actually congruent. If I actually move this down here, the red line will actually cover the blue line, all right? So when you move there, what is the most important thing for you to look at is what the translation is. How much does it go down, and how much does it go left or right, or go up and left or right? That is linear transformation translation. So in this case, what we do is you pick important points, the sort of crucial points that you can identify. Here, for example, you know that this point here is -2 and 4. So you see how it transfers to the other point. Or the turning point, you know the exact coordinate. You can move it down, move it, and move it. So in here, if I actually look at this translation here, the horizontal translation, if I use this point only, if I use the turning point only, you can see that it's moved to the right by 4 units. All right? Move to the right by 4 units. And then vertical translation, you can see that I've moved it down by 4 units. Remember, when you're moving left and right, it's not intuitive. When you move to the right is minus. Move to the left is plus. All right? Up and down is the same. Down is minus, up is plus. All right? So let's have a look at the next slide. So horizontal translation. The transformation f x plus c generalizes the horizontal translation C unit. It doesn't matter what fx is. It could be a cubic, it could be a quartic, it could be anything. So if you've got fx is x cubed plus 2x, fx plus 2 is actually x plus 2 cubed plus 2 x plus 2. All right? You're just basically substituting whatever is into there. Got it? Yeah? So therefore, C inside the bracket is moving left and right. All right? And is in the direction of the x-axis or y-axis. So here, left, I use the word left, but technically you should use the direction of the x-axis. All right? If you're asked to describe, or actually, if you're interpreting what you're supposed to do, this is what it means. If the function is translated in the direction of the negative x-axis, you know that it's moving to the left. All right? Moving positive is plus C. All right? Negative x-axis is plus C. Positive, start again. If you are asked to move in the direction of negative x-axis, the equation will have plus C. If you are asked to move in the direction of positive x-axis, the equation will have a minus C. All right, that's important for you to know. Horizontal translation. So here, two examples. If you're asked to describe the transformation that occurs here, from fx to fx plus 4, how would you describe it? What do you think you should do? Yes? Okay, the line. I would use the word function rather than the line. So the function fx has moved in the direction of the... So I would say that the description is the function fx has moved in the direction of the x-axis by 4 units. All right? So later, I will show you an example where we could actually draw it. The most of the time in this sort of exam questions, you'll be asked to draw the translation. So the next, yes? Yeah, that's correct. So the next one, what would you say? You are transforming fx to gx. Anyone? Yes? Sorry? Yeah. Sorry? A bit louder? Down or left or right? Okay, 2 units right. Okay, so here the transformation is fx is transformed to the right, or actually transform in the direction of the positive x-axis by 4 units. All right, that's important. So then, oh, this one I forgot to write down negative. So it's important to have the positive or negative. I'm pretty sure that if you describe it to the right or to the left, I will accept that. All right, that's not a... it's better to use a technical word because it's in your course description. That's all. It's in the Escasa description. That's why I use that. But left and right, I don't think that's a big deal. Now, the next one is a vertical translation. This time, this D here is actually outside of fx, so it's moving up and down. That's all. So one is moving up is to the positive y direction. Moving down is in the negative direction. All right? That's all you need to know, up or down. Tomorrow, it will be slightly more confusing when you actually look at things like dilation and reflection. Because what you have learned is reflection along the x-axis, but tomorrow you look at y-axis as well. All right. Here, example transformation, fx to fx minus 1. So fx is translated in the direction of the negative y-axis by 1 unit. Same with the next one as well. How do you do this? This is the interesting one. I'll give you a few seconds to play around with it. Yeah?
That's gx. Is that actually changing?
No, it's just a function. It's the gx, that's all. fx is a function, gx is a function. It's transforming one function to the other function, that's all. Yeah. That's no, you still call gx a function anyway. So, yep, right, you're right, Safir, but the thing about it, you're going to transfer, fx, you go from x plus 1 to x. All right? So therefore, that has gone by which direction? Right or left? Because it's minus 1. From x plus 1 to x is take away 1. Correct? So it's moved. Minus is right, okay? So right. Now, you have gone from minus 8. Oops, I use this color, blue. So you have gone from minus 8 to plus 6. So you have moved up actually minus 8. Oh, actually, this is what I should do, is 6 minus 8. So you've moved up by 14 units up. So what I've done is I've looked at the bracket by itself. So I can use this. I can actually put a bracket in here if you need to, if you're unsure. Put a bracket in. So from here, you've moved from x plus 1 to x. So therefore, you're taking away 1. 3 of you at the back. All right? So you're taking away 1. Here, you're moving from minus 8 to plus 6. So it's 6 take away 8 to see the distance. Got it? So therefore, fx is translated in the direction of the negative x-axis by 1, oh, actually right is positive, by 1 unit, and in the direction of positive y-axis by 14 units. All right? Now, I can sort of more or less guarantee you that most of the question in terms of translation will be in terms of graphical format for you to draw. All right? So the first one, I'm going to show you an example. This one. Right. If you've got an fx, this is y equals fx. Fx in this case, you know that there are actually this is actually a stepwise function. Stepwise function. So in terms of stepwise function, you have certain domain that, for example, this is y equals to minus should be half x minus 2, and that's a domain which is less than 0. From 0 onwards to 2 is y equals to x, and then from 2 onwards, from domain of x equals to 2 onwards, or x greater than 2, is y equals to 2. All right? So here, that does not include 0. That includes 0. All right? So let's start off with the function y equals to fx plus 1. Now, what I normally do is use key points. Key points. For example, one of the key points would be this one, right? The other key point is this point, and then this point again. And again, I can use this point. I know the define 1, 2, 3, 4 points. So with plus 1, you know that you're moving this bit. Let's start off with here. Here, up to here, I will draw a circle. Oops, wrong color. I better use a different color. It's easier to see. So I draw a circle. I know that this point is not included. And then from here to here, I know there's 1 point. All right, 2 points there. You should be able to define that line. All right. So that line here, I mean, of course, use ruler if you can. That's it. Then, on the other side, start off with this. This is moved up by 1. This is moved up by 1. So therefore, this is that way. So this is y equals to fx plus 1. Got it? So, vertical translation. Next one, horizontal translation. Plus 2. I know I've got to move to the left by 2. So start off again with this point. Move across by 2. Start off with this point. I move across by 2. And then I can draw that. Oops. Actually, that point is a full... Yep. I would draw that. All right. Hang on. Again, I used the wrong thing. All right. So draw that one out. Okay. So follow suit. This point here will move across by 2. Same with this point, move across by 2. Therefore, you can draw the function. All right, so here that will be y equals to f x plus 2. Now, what about the next one? Y equals f x plus 2 minus 1. Which one do I do? Move down? The red one. I move down because I've already translated this across by 2, correct? So I move down by 1. Got it? Yeah? So moving down by 1, hope you can see this green color. Actually, I might change slightly different color if I can. Yeah, use a purple color. So here I've moved down by 1. That's 1 point here. Move down by 1, that point. So draw it. And then I move down here by 1. This point move down by 1. So, and that's the case. Sometimes, in terms of stepwise function, you may have different sort of graph. You may have something like this. The last example I'll show you, not today, probably Thursday, you've got something like this. And then you have to know how to transform those. Okay, transformation is what you do. Today it's just translation is what you do. So this is y equals to f x plus 2 minus 1. All right, next one. I would like all of you to try this, please. All right, try this, please. What I want is sketch it. Can you sketch it on your book? If you haven't got a square paper, get some square paper. You know a few points. All right? So you know a few points in this case. I can tell you the important point here, the crucial point will be here, turning point. Turning point. Here, this point crosses, you know there is, you can read the coordinate, and you can read the coordinate from here, 4 points. How would you actually translate that? So first one is down 1, so every single point here, you actually draw it. Now, I always advise people to look at the points and always use point. There's those important points that you can tell the coordinate to actually draw it. So it's a little bit difficult. It's very close. It's something like this. All right? So the next one, x minus 3, you move it to the right. So here you move this point to here. This point to here. This point by 3. And this point by 3. So, sketching it. Oops.
Sir, I think
This one.
yeah.
All right. Generally, you can tell whether you've done the right thing or not. And finally, the last one. You move across by 2 and then down by 1. So move x minus 2. You move across. Start off with this point, 2, and down and up by 1. All right. 2 and up by 1. 2 and up by 1. And 2 and up by 1. So this is how you do it. All right. So I better label it f is x minus 2 plus 1. F, this is y equals to. Always label, if you're asked to do this, y equals to f x minus 3. And finally, y equals to fx minus 1. All right. Now, I'm going to stop here. Exercise I have uploaded on Google Classroom. You need to download the exercises that I gave you, and there's some exercise in Settler as well.